Invocation and lighting of the Kutturalakku. Every event special. Now I invite Dr. R. Saravanan, Professor, Department of A&ML to deliver the welcome address.
It gives me immense pleasure to welcome you all to the CSF sponsored 2-day seminar on Unveiling the Shadows, IoT, Forensics and Cyber Defense, organized by the Department of Computer Science and Engineering, AI and ML. We are highly honored to have with us our respected Principal, Professor Dr. E. Kamalanavan, whose continuous support and encourage in all the activities. Welcome sir. I take this opportunity to extend a special welcome to our eminent resource persons from Infosys Limited, Chennai, Mr. Vinod Kumar, Senior Technology Manager. Welcome sir. And Mr. C. Suresh Kumar, Principal Consultant, Infosys Limited. Welcome sir. Their expertise and industry experience in IoT security, cyber defense and digital forensics will certainly enrich our knowledge and provide valuable insights into emerging technologies, challenging and solutions. I also welcome all the deans and HODs from all the department, professors and faculty members for this program. I heartily welcome participants from various institutions and our institution to eagerly participate in the 2 days national seminar. I sincerely thank the Council of Science and Industrial Research for sponsoring this seminar and encouraging academic initiatives that bridge the gap between industry and academia. I also appreciate the efforts of our head of the department, faculty coordinators, organizing committee members, student volunteers and everyone who worked tirelessly for the successful conduct of the seminar. Once again, I warmly welcome you all and wish the seminar a grand success. Thank you.
For your warm and inspiring welcome. Now it is the time for the inaugural address. I respectfully invite Professor Dr. E. Kamalanavan, Principal, to deliver the inaugural address.
Honorable Founder, President and Chairman, Honorable Professor Sri Dr. R. Rangarajan, Honorable Madam Dr. Shakuntala Rangarajan, Founder, President and Chairman, our respected Chairperson, Managing Trustee, Dr. Mrs. Mahalakshmi Rangarajan K, our Assistant Director, Ms. Yaskinda Kishore Kumar, our distinguished resource persons for day 1, Mr. R. Vinod Kumar, Senior Technology Manager, Infosys Private Limited, Chennai. The other gentleman, Mr. C. Suresh Kumar, Principal Consultant, Infosys Private Limited, Chennai. And day 2, Mr. B. Satish Kumar, Senior Project Manager, DXC Technology, Olympia Tech Park, Gindi, Chennai. The other resource person for day 2, Dr. S. Edwin Raja, Associate Professor, Department of CSE, Veltech University. And the person who got this seminar grant, Saravanan sir of AIML department, and the head of the department, Manoj Kumar, faculty members of Artificial Intelligence and Machine Learning, and other heads, professors, and my dear faculty, participants, students, participants. Very good morning, all of you. This particular CSIR sponsored 2 days national seminar on Unveiling the Shadows, IoT Forensics and Cyber Defense. March, I think February end, March, we started applying for seminar grants with some thought, that we had something and called for a meeting and asked people to apply for the seminar grant, out of which the one gentleman, Dr. Saravanan, got this CSIR sponsored 2 days national level seminar. Rest I do not know what is the status, but நிறைய கைதட்டலாம் அவருக்கு. ஒரு ஸ்பாட் மாதிரி தான் இருக்கு. Yesterday they were saying that today is a seminar grant. என்னப்பா என்ன 2 days program they are saying it. I asked where is the schedule, what is happening, who are the participants and other things, but resource persons. Today they have come here, I think fruitfully these 2 days, which is really essential. The topic IoT forensics and cyber defense. Always we require defense. Anywhere you go, kind of mechanism, defense mechanism is required. Generally, wherever you go. இப்போ அப்படிதான் இருக்கு, வாழ்க்கையே அப்படிதான் இருக்கு. எப்படி நம்ம பாதுகாத்து போறோம் அப்படின்றத பெரிய விஷயமாவே இருக்கு. So that technology is for both. So for good things, how you are going to protect the technology and see the security breaches, how it is happening in today's world. See how the hacking, the bank account opening, the bank account, what you have the savings. After some time, you do not know what's happening with that hacking, and so many things are happening. Bank zero balance and everything. Now, this is how speed people are working behind so against the technology. So both we have plus and minus. But anyway, the professor what he has chosen the title is good title, and I think the participants who are here fruitfully these 2 days, day 1 and day 2, you are going to get some useful inputs. That too, they have invited from software companies, Infosys, reputed top MNC company, and other companies like DXC and other things. Really, because people they are looking into, practically they are seeing it what's happening, with the technology and the people, how they handle the technology and how they find the solutions for different problems with the technology. So this is really important. I think the department have done a good job in inviting people from industry. So mostly academicians they come and deliver, but practically to talk much about all these technologies, security breaches in terms of IoT, Internet of Things, I think right people are here to give you some knowledge. So really great. Once again, I thank for inviting for this 2 days national seminar. Wishing you good luck. Have a great day. Thank you.
Thank you, sir, for your motivating and encouraging words. Now we move on to one of the most honorable moments of today's program, the felicitation ceremony. It is our privilege to welcome and honor our distinguished chief guests for gracing their seminar with their valuable presence. I take immense pleasure in introducing our respected chief guest, Mr. Suresh Kumar Chandran, Principal Consultant with more than 24 years of experience in the IT industry. He is an expert in data architecture, cloud data migration, enterprises platform administration and automation. He has worked with leading global organizations including Infosys, Cognizant, Ramco Systems and Polaris Software. His contribution in digital transformation and AI initiatives have inspired many professionals and students in the technology field. May I now request our principal to kindly felicitate Mr. Suresh Kumar Chandran with a token of appreciation. Thank you, sir. Our next distinguished guest is Mr. Vinod Kumar Radhakrishnan, Senior Technology Manager with 20 years of experience in enterprise scale solution, cloud modernization and digital transformation. He possesses strong expertise in AWS architecture, data engineering, AI and Gen AI technologies, led global technology teams and contributed to innovative AI-driven solutions for Fortune 500 clients. His achievements in AI innovation and modern technology leadership truly motivate young engineers and aspiring developers. Dr. Jino Jasmine, ma'am, Department of AI and ML, to deliver the vote of thanks.
To give this vote of thanks, and I express my gratitude to our principal and our management for this great and constant support for this event, and I extend my thanks to Professor Saravanan sir as well as our HOD Dr. Manoj Kumar DS, and very thankful to our participants and students who are supporting, and then I am very grateful to resource person who are spend the more time for here, and I request participants to use this time, and you can get practical knowledge from them. And very thank you to all the members who are here to support this event for a great success. And now the tea break is there, and then next the session will start by 11 o'clock.
Let's get started. Today we will cover the seminar. We will cover about the IoT and IoT ecosystem, and then the fostering, how the IoT fostering is going to help in terms of addressing the cyber issues, right? So before going to that, I will try to cover what is current trends, especially in the industry. We both are from industry, right? In the IT industry for more than 2 decades. So how things are evolving, right from the era where we were seeing from legacy systems to cloud, which is there. A decade back was a trend in the market, right? Where every customers started migrating from the legacy system to the cloud platforms, to be AWS or whatever market leaders. But that trend slowly now is changing. I mean, now in this current era, we are seeing AI. Current era, we are seeing the AI, right? AI, how AI and agents, right, kind of transforming the industry, right? Especially from automation to autonomy. So typically, IT sector tries to does the repeated work by automating certain tasks, certain tasks, right? But now how it is becoming more autonomous, right? Currently, the traditional IT was more of a repetitive task, but now what we see is with the evolution of agents, right, how things are changing, right? Especially these agents making things more adaptable, talk to each other, how they are making the workflow, running the pipelines, workflow on more autonomously, right? So that's where we will touch upon how these trends, right, especially the AI and agents, right, making things more autonomous. Coming to the solution, coming to the second part, which is AI gateway, right? How an enterprise now become AI first. Earlier it was like, as I said, we have different streams, business lines, everything had their own set of streams of process. Now because of this AI first approach, the entire system is getting changed where AI is across all the business process now. They are trying to understand the decision making is becoming driven by the AI agents, right? And how the system continues to learn and optimize itself. So this shift is enabling faster innovation and improve the operational efficiencies. So coming to the rise of agents, right? So initially, as we say, right, one of the most significant trends in this emerging is the agents. How, especially the AI agents, if you look at, right, they can plan, they can reason, they can take an action accordingly. So, for example, let's say IT operations, right? Typically, we monitor all the metrics, especially the jobs or other system observability. Now, everything is being autonomously captured, and there is a remediation also. If there is a job failure, system acts on it. If there is something, there is a issue, the system is trying to understand the root cause and give the inference so that human in the loop, human takes the action based on the observation from these agents, right? The agents ask the humans to guide what to do next, but still it is not the human is doing anything. Human can say yes or no. If he says yes, it starts re-triggering the jobs, or it could be rerunning the process. So that's how things are evolving and changing. So especially when it comes to data, data is the foundation for all this AI, right? Because without data, right data, you cannot deliver the value of the AI. So getting the real-time data using the pipelines, or it could be scalable platforms like today in the market, source or the products, industry products like data lakes and the data lakehouse. So these things are kind of giving a different perspective in terms of managing and maintaining the data, right? So the next one is how AI and AI workforce. So traditional way of work, it let's say I have a development team, I have 10 developers, now it is changing to 4 developers and we have 6 agents, right? So it is not no more human centric. The human involvement of the developers are now being reduced in the industry. They are looked upon how we can leverage as a developer, how can I leverage the co-pilots, right? Because today LLMs are generating the code and 90% of the work LLMs can generate. But how that data can be validated? You cannot trust AI generated code, right? So today we have probably we have at the POC level we were able to implement many use cases, but when it comes to production grade or enterprise grade application, AI is really no, it's still in the challenging phase. But of course, there are some mechanisms, especially exponential engineering, forward deployment. So through this approach, how we extract enterprise grade code from these AIs. So that's where the agents we have standards like what do you say like skills. We have what do you call that? There is a terminology, spec engineering, right? So with that, the AIs are more becoming smart in terms of understanding the requirement. It generates the plan. We review the plan. So human can look at the plan generated by the agents. We can change, for example, the understanding of the AI, right? Let's say it understood the requirement, but it's not as what expected by the business. Then you can change that. So there is every step it gives you, right? So let's from the plan, it gives you the design. We can review the framework, and once you approve that, it starts building the solution. So it becomes more controllable now. And we have a lot of skills today which agents understands how the structure, format, everything, right? I have some standards, coding standards. There is some architecture principles. So for each, there is an industry, there are many industries now started putting skills. Skills are nothing but basically a set of prompts which suggest or which guides how to build this application, right? So the trend is moving towards how we build, leverage all this and make more agent-driven team and the code quality, everything generated, right? We have a reviewer agent, we have a tester agent, we have a developer agent. So there are a lot of agents. So how it is going to augment humans and we get a production or enterprise grade solution. Okay. So in the next slide, we are going to see about how cyber security, how AI is influencing, and at the same time how AI helping, right? Because there are a lot of AI powered cyber attacks currently, right? At the same time, we are also seeing IoT device, everything now under attack because of AI-driven cyber attacks, right? So how we secure that by probably more shifting from the perimeter based to zero trust architecture, how we are going to increase the attack surfaces, IoT edge devices, right? So keeping all your performance, everything in the edge AI rather than sending it down to the IoT platform. So these are some of the things. So the convergence of IoT and AI, the real-time decision is making at the edge and also reducing the latency for the better performance. So this is the future outlook. Today we have AI augmentation and where, as I said, right, it's going to be fully autonomous system. It's going to be a self-healing infrastructure. No more earlier cloud made us a lot of things easier. It gave we can split the instance very fastly. Earlier it used to take a long time for the network configuration, everything. Now after the cloud era, it has become within a few minutes. Now, with the help of AI agents, how these are being monitored, how things are currently observed, and there is a use of agents to act on top of that. If there is a server is down, there is a observation from the agents. It gives you the predictive or reactive. There is a reactive action whether to restart the server or if it's a predictive, it can give you potentially when the system can go down. If there is a more CPU utilization or if there is a performance degradation happens, then that agent identifies that and notifies them human to either take an action, right? Based on that, some of the agents can go and act on it. Either it can generate root cause analysis and give it to the developer, and the developer can, and the application owner, support agent can take action on it. Okay. So this is a trend so far we have seen in the industry. Let's go to the today's topic about introduction on IoT forensic and cyber threat landscape. So let's cover what is IoT ecosystem all about, and then some of security challenges and the importance of forensic analysis. So yes, everyone knows, right, what is IoT. In our day out we are facing that, especially right from the smart homes, right? We have Alexa, we have many sensors in our ACs, everything is now captures, right? Fridge, many devices, you have your wearables. So all these are all IoT. Basically, the thing that connects to the internet is what IoT, right? Internet of Things. So all these devices are connected to the network, right? So basically, there is a firewall, and they have the gateway. Through the gateway, they connect to the internet world. So they share the data to the cloud, and the processing happens. So basically, different layers. One is my device layer. That's my first layer. See that in the next slide. So this is my high-level understanding, right? How the devices capture the information. It could be when I talk about one of the use cases. So there are other industries like manufacturing industry, there are medical industries, there are transportation industries. So it captures all the metrics that needed for the business to run, right? If it is, let's say, a transportation, I would like to understand where is my vehicle, how much speed it is going, or what is my capacity, petrol, what is the capacity of the petrol, what is the emission of engine, is it controllable? So all these metrics are now being captured. There's billions and billions of data, billions and billions of data is being getting right. So what happens now? It's really a challenge for us to process this data and how we efficiently get insights out of this data and act on it. So typically the data gets here and it's getting transmitted over the network layer to the internet, and processing happens in the cloud. Typically cloud is a preference because you can scale up any time as the data increases. And then you expose that to the end user, right? Whether I have an application to monitor that, I can take an action. For example, you have smart appliances, you can switch on, switch off. So you take an action, and that action again flows back to the cloud, and then it just reaches to the devices, right? And then device take an action. There are multiple types of devices. One is sensor, or one could be actuators, where it opens a valve or take actions depending on the signal, right? So yeah, this is a high level. Let's go in deep into the layers. So this is the different layers as we speak, right? One is the first layer is device. First layer is which I spoke about devices, sensors and other information. The second layer is the communication layer, where it transmits the information. So you have Wi-Fi, Bluetooth, they're different. It depends on the short to long range, right? So if it is what do you say, like Bluetooth is for short range. See, for example, if you have a factory that monitors all the sensors, or it operates surveillance, everything. So those are all interconnected to the Wi-Fi. So those are all small range. And finally, it in turn connects to the long range network to proceed to the cloud computing. And followed by there is a data analytics and vision language, right, where we observe the trend. So what it does, with vast amount of data, the system analyzes to drive the insights, right, and then makes the informed decisions. So basically, data and machine learning techniques are used to process the analytics and extract the meaningful. Finally, that is being served to the application. So that's where I told you have application to monitor. It could be smart home or healthcare devices, or it could be transportation, or any industry. Today it is expanding across all the industries. Okay. So this is the data flow. As you see, we sense the data, we transmit, we store, we analyze, and act on it. So that's the flow of the IoT ecosystem. Moving to the next slide. Yeah, I think we'll see the component. I'll not probably take long time here. It's more about layer by layer. Right? The first layer talks about the sensor devices. So what are the devices and how the typically data is transferred. So at least what we will touch upon here, the common type of data. One is temperature, humidity. These are some of the information that are being collected, right? Especially GPS location if it's a vehicle, and industry. There are medical industries that capture the pulse meters, and there are other key attributes like oxygen levels, everything you track and monitor. All operationally in hospital also, not just about the patient level. Across the industry within medical, right? There are many factors to monitor on a day in, day out. The second component we will talk about the communication network. So this, as I said, from Wi-Fi to Z-Wave, right? We have multiple depending on the bandwidth. So I will probably see. Yeah, so this is the next layer, right? Where the cloud, how the cloud is coming here, right? Especially you have device management. So cloud helps you to onboard the device, right? So you typically have the provisioning of your OS patches. For instance, for example, I have to onboard my new devices, monitor the health, push the OS, right? Firmware is nothing but the OS for the devices. So basically, the cloud as an IoT platform, it pushes the data, it pushes the patches, all this regularly so that the system is having the right patches updates so that it is not exposed to the attacks. So followed by data ingestion. So typically QTD is the common platform used by major of the service providers that receives the data from millions of devices simultaneously so that it starts and getting the data stored again. So for such a huge data, we need to have a time series kind of database, right? Like Influence or Timescale or cloud providers such as Azure, which gives you the time series data. And you have today the digital twins, right? You have a kind of clone, a similar environment and see how things are, right? You have the monitor how it's like a stimulation environment, but more than the next gen. How my environment is going to react to this digital twin. So as a production grade, for example, in let's say the public transportation, you want to understand how my data is going to impact. So you cannot virtually create a lot of heavy traffic and learn from it. So you can create your environment so that you can test and validate your application performance. Yeah, so this is the next stage is about the data and pipeline. So basically, again, how we collect the data, how we cleanse that, because the data we collect is not always a production grade. So you need to profile, you need to duplicate some of the data, you need to improve the quality of the data. Sometimes the sensors may not give you the right data. So how you enrich your data so that the system understands it, right? So all the data, it could be streaming or batch data. So always data profiling is one of the key part of the data analytics, right? And then because that data going to serve you the machine learning, and it can take appropriate understanding and appropriate decisions, so that it could be predictive or anomaly detection, etc. Right? And so that it gives you actual insights. Yeah, so this one again, just a high level of your applications which I talked about, the end user, right? I can have a smart home automation like applications to control via mobile apps. Second is on the healthcare side. If you look at this monitoring, today we have a lot of healthcare devices which monitors, for example, our insulin, diabetes patients have started using the US. They can continuously monitor the spike of the sugar. How it is that? It's all through this IoT devices that captures from the as a patch is being injected into the body, and from there it starts giving the signals, and accordingly they can observe this whether their glucose levels are under control. So as a human, I can take action against whether should I control my diet and plan everything. So to see the level of importance, and it is growing across the speed at which it is growing, right? Today, at least the last 4 years, there's been a tremendous increase. Like it has started, now every homes today have all these smart home devices, and look at the industry level or even jobs, right? Today they have the smart sensors, they understand whether my quality of my stock is getting reduced or not. So it is going across the industry, not just about earlier it was only specific to customer centric. Now it is going or a medical, so it's going now beyond that and going to the each and every industry segments. So that way it benefits, okay, because I don't need to monitor my warehouse or even my, let's say I have a retail store, right? So I want to, no need to go and see the IS, right? I understand whether the product is moved, okay, I can go and do the replenishment. How can I do the replenishment? I don't need a person to go and monitor every IS, right? There is a now IoT device that senses, okay, the boss, there is a date tree, there is a, these are the products I want. So again, there is another robots kind of thing that go and fulfill, go and place the particular products there. So that's how the industry is moving, especially retail and supply chain industries, right? So there are more to come, especially with adoption. Yeah, again, this is just the overall end-to-end flow. So I'll just skip it this process. It's already been covered most of this, how the physical world is being observed and monitored and action being taken on top based on the observation. So these are the typical benefits. Again, I don't want to touch more here. It's overall, if you look at the ecosystem of the IoT, it helps us to increase our efficiency. It saves the cost. Obviously, the customer experience is one thing which everyone being inspired of it. And finally, the safety and security aspects, right? How it helps helps ourselves, especially in terms of monitoring our health, as I said, and the security aspects, like how today we have a lot of smart doors and surveillance cameras. So how, and with all this AI powered up to it, right? We don't need to even monitor everything on time. The alerts getting generated when somebody comes through, somebody take any action, or any voices recognized. Right? So this is how the benefits keep on rising in all the industry. So what is the future? As I said, right, we should be very much look at how it is going to expand in the near future, especially from the major four standpoint. Okay, what is the advancement of technology? As I said, with all this 5G networks, things become more faster, data can be transmitted faster, and edge computing network. We don't need to circle out all your data to the IoT platform and then do the processing and then go. Since we have everything in the edge itself, let's say a flight, we cannot have a flight always connected to the network and understand or observe the metrics of each equipment, right? So why not we can have a small processing engineer or small models which can run within the edge location, and that can probably give the insight by monitoring the data. So you don't need always to have internet connected to that. You can always have a closed server, or you want to keep it more private. I think this edge device or edge computing is going to be the next era. Especially the chips are more designed towards that, adapting to the very less volume of processing. And also, as I said, the models, right, lightweight models or lightweight protocols, everything is now being taken up for processing. The other one is industry standardization. If you look at organization, or it could be a national level, for example, Europe, right? Europe don't want to share the data outside the country. Similarly, there are other regulations and guidelines today coming up every other year, right? So how to adapt to that, and how it just encompasses with that standards, and how it builds the guidelines to that, right? That is more the going to be future, right? You don't want the data to be more secure today, right? Because a lot of devices are exposed to the threat, which we can see in the upcoming slide. But this is what going to regulate, okay, how we going forward, how we should keep our data, what is the boundary it is supposed to be, whether it should be within the zone. I think that's where today we probably dig deep in the upcoming sessions. Okay, the last one is about the sustainability. That is very important, right? As the device grows every year and year, look at the number of power consumption, or it could be the wastage, wastage, or how we can be more smarter. Like how can I use the solar instead of powering all this, right? More towards going into the eco-friendly environment, and how I can manage this e-waste. How can I dispose? How can I also consider about the privacy and surveillance concerns, everything, right? So these are the future scope for the IoT ecosystem. Let's go to the next slide. So these are some real world cases which we talked. I'll just quickly skip here. There's nothing which we spoke about and look at the operational efficiency of the industries have gone by 25%, and also the maintenance cost. It predicts if the mission, right? Let's say the mission is going to be serviced every certain time. So it monitors the parameter of the mission and it tells, okay, you're this particular, you need to do what are the maintenance. So my maintenance preparation and everything is coming under control. I don't need to go for an outage where it saves 20% reduction in that, and overall the product quality increases by 15 to 25%, and of course the energy reduction, right? So these are some of the real world industry level savings. So let's go about the risk. Okay, security risk, especially we talked about all the ecosystem, right? How and what are the challenges we have? So basically we have multiple layers, right? This is our IoT device, right? But how it is surrounded by, like it has a firmware, as I said, the OS and patches and all the authorizations and crypto keys. See how this device, basically this device is kind of very disconnected, right? We place the device outside, how somebody can hack it if they don't get the device, right? So these are some of the issues that challenging we have. Cryptography, it could be weak authentication or security misconfigurations and open AI interface, especially when the data reaches to the platform through the network, right? Whether the APIs are secured, how we have the SSL connections, how the keys are secured, the data is encrypted at rest as well as in the transmission. How we see whether the regulation compliances and then the chain of trust, all these things are the potential risks. So we have to observe that and also address it, especially when we implement such a IoT system in any industry, right? Some of the common challenges I mentioned is default credential, right? So generally, I know many of you, we buy a product, okay, and we just use it as such. We don't go and change the default password or admin password. Most of the cases it will be admin or it could be a root folder, right? So how, if you look at more than 6 lakh devices still, right now they are not, change the password, they just go with the default password. So which is a kind of risk, right? And also unpatched firmware. As I said, unlike PCs as smartphones, right? IoT devices often have no automatic updates. So basically, a device manufacturer has to ensure to release the patches on time, and also the device being in the remote location, it should have a capability to get those updated patches. So that's where the challenge now manufacturer simply stops supporting the products. Then those are the vulnerabilities, right, which remains unidentified. And many industries, especially the IoT productions are running firmware from 2015 or so. They're not up to date. They're not keep on getting the upgrades. Okay, since the location, since the device is being stayed away far. And third is the encryption. So if you look at, as I said, right, this is a lightweight protocol, MQTT, right, which is like again, if you be not secure, it transfers the data in the plain text. So we have to make sure it's not in the default configuration. We have to secure that. We have to encrypt that. So the older implementation we are using RC4 and web, but both are broken. So everywhere encryption exists, certification validation is also disabled. Also, we have to make sure the certification is also up to date. It is also enabled. It's properly, implemented. So that is one challenge, especially in terms of data which is being transmitted over the net. And as I said, the minimal compute, right? Because the microcontrollers today running with the wireless megahertz, right? So hence they don't have the cycles to run full TLS action. And for every sensor reading, that's a challenge. You cannot. Basically, you have to do a trade-off because the lighter cryptography generally share keys and no encryption at all. So this is a genuine engineering constraint, but there's no other role we have to tackle it. And the other one is a supply chain. So when it comes to the manufacturer, right, there are multiple devices out there. Especially you have a lot of third parties. You have Bluetooth chips, you have cellular modems, you have camera. These are all not tied together. These are not single product, right? There may impact vulnerabilities at the manufacturing level. So that gives a ripple effect. Like millions of devices with this as a problem. So, and finally, there's no secure logging. So if I wanted to know what happened 6 months in my device, definitely they don't have that level of monitoring. The syslogs, everything was not being exposed or being managed at the time. So these are some of the common security challenges. Let's go to the next, where from the layer standpoint. which is looked at by the device level, by the network level, and at the cloud level. So of course cloud is secure, but it is more of handshake, right? It is a shared responsibility. You cannot rely, okay, just because I implemented everything in the cloud, that doesn't mean it's all safe and secure. I am also equally responsible to control that within the cloud. So from the device perspective, you have this firmware extraction and reverse engineering, and this JTAG and UART debug port exploration, because you should not, if somebody gets the device in hand, right, they can probably easily connect to the port and go to the central repository and get it dumps around. And this is also boot sequence, as I said, right? So these are some of the device related. And network related, as I said, QTT, right? And man in the middle is particularly common in the encryption, right? They deploy where TLS is not, but certification may not be valid. So that is again might be disabled. And there's BLE type, which relay attacks exploits devices that authenticate based on the static token. And as I said, in the cloud, everything is API key, so you should not save the keys in the cloud. You have the vault for that, you have a secure vault that encrypts your keys. You should not ever go in your virtual machine and store it as an environment file. So many things are there, right? So it's just because it's cloud, it does not mean that I can say, yeah, it's secure, not like that. So you should secure it, and the API key extracted from firmware is also kind of having an effect. Developer really should embed it how API's secret directly in the device firmware. And we have these tools like bitwalk and string analysis that reveals these in seconds. Okay. So the recent, I think 2016, I think we got some where the device was simply find out 16 default credentials. Okay, and it has compromised over 6 million devices. So which means that they were able to launch it like a DDoS attack, picking them like GitHub, Netflix, and other portions of internet. So the source code was later released, but over dozens of variants, it was impacted, and it was really a major issue in security. So let's come to, so far we have seen on the securities, right? Now let's understand how this WhatsLink is going to play a significant role. So what is this, right? We have established IoT large and heterogeneous and severe. Now let's probably make it the case why WhatsLink is not an option. It's more of a legal and professional obligation, right? So if you look at how I see WhatsLink is a disciplined practice of like, let me identify, let me collect, let me preserve and analyze the digital evidence for the IoT net to reconstruct every attacks that happen, attribute and support the legal entities. Okay. So where it is purpose, right? One is some incident is I have to respond to the incident. Let's say something happens, I have to understand what got compromised, when it got who, what data was exploited, and also the regulatory. If you look at as I said, right, there are some regulatory acts in the UK, 3D where they must notify superior authorities if there is a personal data breach. I think within 72 hours we have to report loss of, including the breach category and the data affected and consequences, right? So these are some regulatory aspects and also guidelines that has been set, and also for legal. When there is any issues, we have to support regulators are increasingly expect the organization to provide evidence on their devices. Like, let's say if it could be criminal investigations involving smartphone devices or IoT data that is used as a direct evidence, right? So these are something they have to appear at the proceedings. So if you cannot produce the evidence, it's a forensics forum and it might be inadmissible. So, but what are the unique challenges in terms of getting this data, which is corporate, especially the proprietary OS is one of the challenges, right? It's a unique challenge. The proprietary OS protocol, because you don't have a standard protocol yet. As we say, there's no universal. You have a ZP, you have ZP, different protocols we are using today in the IoT world, right? And this MQTT broker on the gateway is also speaks in a different language when it goes to the factory floor. So there are a lot of standards are not being there because of different level of instruments being involved in this cycle, right? Second thing on the volatility of the memory loss, right? So let's say when the device is switched off, I don't know how can I access when the RAM is wiped out? How can I understand what are the devices that are not connected? What are the encryption keys? What So those are the challenges because I cannot access the device. Now how would I end up getting the traces of what happened before the device is attacked like that, right? Second is the other one is no, as I said, right, native logging. So most devices don't have this syslogging, right? So what happens? The first thing you is to rely on the network package only. If you don't have the syslog, you have to go with the cloud APIs and physical and hardware analysis provided to get the access to that. So these are some of the fundamental challenges. Of course, there's a multi-vendor implementation which we talk about, right? There are many devices are there, right? Different manufacturers require different way of extracting the tool. So all this are also concerned. Of course, and finally the legal complexity in terms of GDC, right? Where the cloud data associated with the IoT device often sits in the foreign place, right? You don't have control. With the device, you cannot ask the UK government to give me data which resides on their cloud infrastructure. So there are some laws and legal US cannot go and claim on it. These are some regulatory challenges also there. But how we can overcome that and what kind of process we follow in order to take that right? One is so basically this is our investigation process. One is how I identify, how I preserve that, collect it, analyze it, report. And that is one of the pipeline which will end-to-end process to detect the incident. So one is let's go a little bit on the 5-step process, right? Before you touch anything, you need to understand what are the devices, right? You need to understand documents like what are this environment, what is this make, what model, what version it is, what kind of IP address, MAC, details, everything should be observed when it's in the current power state. So, what is the purpose? We're going to draw a network topology with the information. If one does not exist, then ask the cloud services to do the devices. So, manufactured. It's still under support. So all these things we have to identify first. And second is preservation. So one of the most critical steps I would suggest is preservation, because if a device is powered on, you must capture the volatility in our memories first, because when RAM, let's say if you have to still connected to the network, trace all your RAM related data, which contains all the running process, open network, which has encryption keys, patches, session tokens. Those things will disappear as the moment when the device goes off. So after volatility capture, isolate the device from the network so that others cannot go and tamper the data, right? So you should place them in the kind of a far away or to prevent the remotes for piping data. Do not allow the devices to communicate while it is in the when it's backed up. So many smart devices kind of receive that OTA commands that can alter or wipe the data. And finally, you analyze it. So after we collect, the next step is to analyze it. So what we do? So you have the evidences in your hand. So what you do is you have to do the pipeline reconstruction, so which we will cover in the next slides. But more than that, we have to report. Basically, nothing but you cannot be presented efficiently, right? Your report must include the custody, the chain of custody document, the tools and methodologies used, as well as the costing images. So that you have a clear narrative, you have a mixture of so it must return a mixture of audience, technical and non-technical decisions and also legal matters, right? So this is the kind of high-level principle, right? All your fostering actions, right, must remain chain of custody and follow the order of volatility. So we will probably dig deep on what is chain of custody, what is the order of volatility. Well, actually, what are the data we need to capture first when some incident happened, right? Whether it is RAM data, or should I go to the network data? So there is a sequence of order which we need to capture, and also chain of custody is again a standard principle and framework. Okay. I think that's maybe we can cover the rest. Yeah, after the session, we'll break. It's already 12. Any questions? We can discuss.
CSCF sponsored seminar program. Second session is going to start. I request Mr. Suresh Kumar Chandran, Principal Consultant, I welcome sir. Thank you sir.
This session will talk about the forensic techniques and tools for the IoT devices. In the previous session, we had seen about the IoT's ecosystem and what is its attack surface and what are the why forensics is essential for us. So those we will cover up, and we will cover up in a couple of sections like data collection and preservation, firmware analysis and reconstruction, forensics tools and applications. In those areas, we will cover details of this. This is a brief about the data collection and preservation areas, where the evidences and sources, these can be collected from multiple areas like device flash, cloud API, network traffic, mobile app, and companion app. So from these areas, we can collect the data as an evidences, right? And when this evidences is being taken, where we get more details. Those details are like CPU registers and cache, RAM, content memory, network state, running process state, flash memory, and RAM, logs and coordinates. Based on this, we will be taking it. Why this is required is, unless and until we keep track of this data, this is at that particular point in time, this will give us more clarity on what has happened and when has it happened and those kind of information. So that's why these details are much needed. These are the methods, right, where how we will be collecting the data for this forensic purposes. This can be done in two ways. One is when the system is live or when the system is not live, right, active or passive. When the device is live, right, so we will be taking the running process, what are the things, and what is the memory usage, and what is the network connection which is active. Those kind of information will be captured. And when the system is not active, like the system passive and those kind of things, we take different set of data based on the things which is in place, like flash and taking the checks off and then doing the ISP extractions, those kind of information. And whatever the data which is being done, it has to be hashed so that we will be having the checksum of that particular data. When these things are done, we need to have the evidence package. So these are all has to be consolidated and packaged, and then if that particular data is in the cloud, then we need to have a requisition like chain of custody files and those things need to be released. This custodian requires why this will be released in the cloud. They may be cleaning up the data for some period of time. So at that particular point in time, if this information is needed, it will be held in this. Why is this? There is something like you can correlate to real life instances. If the kind of say any incident happens in real life, right? The device, it will go with the configurations, its own set of configurations. So those configurations can help on doing the analysis. There are specific set of tools and applications for in the forensic at different stages. Firmware extractions. Have few set of tools like Windows, Backbone, OpenOCD, and we have firmware. These things will be done for specific purposes. Like Windows is a firmware analysis tool which is open source and it's a command line based. People can use it from the Linux command prompt and do the analysis. And flash ROM is when you read want to read or write in the flash checks, this will help to do the analysis. And OpenOCD is JTAG debugging interfaces, like how we do the we can correlate real-life incidents, like when you use a mobile, you can go into developer mode and get some information. Right? Similar to that, this will also help to go in debug mode and get the system information. It will help in doing the analysis. By doing this, we can call the execution of the device, rewrite registers, and take the dump of the memory and those kind of information we can. And we can see about the reverse engineering. There are a set of tools which are available, which is helps in IoT forensics. The one which is Vitra is for decompiler, which is helping to do the decompiling of the things and take the readable information from the device. This particular tool supports around 40 plus processor architecture and computer analysis. This is like when the laptops are desktop, we can put simulators and put some devices and then do that. Similar to that, internally helps multiple processes. And about network and traffic, there are set of tools like Wireshark, Scapy, and everything. These will help you do the set of analysis and platforms. Right? We have FAC, Autopsy, IoT Seeker, and the set of devices. These will help you to do the analysis in those areas. And whatever the set of tools is, you would need to do some tool selections so that based on that particular environment, based on that particular architecture where the devices exist, you can. So we may have to match the tools to the access level available, like JTAG or OpenOCD or network capture, whichever is applicable. We need to pick up the corresponding tool and do this analysis. When we talk about the end-to-end investigation work, okay? So these combines with a different set of series, like combining the collection, firmware analysis, tools, and to complete IoT forensic investigation. This will help to collect the data and do the analysis. And what about the scenes and how we do the acquisition, how we do the verification, and how the overall analysis is being done. So this gives a sequence of the activities that needs to be done for that particular as a kind of workflow. Overall, during the first session and the second session, we spoke about the IoT landscape and why forensics is needed, what are the trends and why we need to do this. So this slide summarizes those activities. Where in IoT forensics needs specific or specialized knowledge to do the analysis and to do the activities. And we have specific set of tools which helps to do this analysis so that we will have the information which is available to do the investigation on the incident. This we can call early to the real time